An exciting, fascinating world of chemistry. We're looking at solutions, and today we're looking at concentrations. Now, there's two units of concentrations we're looking at today. The first is molarity. Molarity is defined as moles of solid, the substance that is dissolved, by liters of solution, the homogeneous solution mixture. And the symbol for molarity is a capital M. So look at a problem. We'll do this one class. Calculate molarity of 17.65 grams of sodium chloride and 350.0 milliliters of solution. We'll do that one in class. Now, this one we'll do together. Find the mass of copper 2 sulfate needed to make 250.0 milliliters of 0.7550 molar solution. Now, whenever I give you two values, you have to ask which one you start with. Well, we're never going to start with a concentration. So that concentration is 0.7550 capital M molar, as we just discussed. That's a concentration. So we start with the other value, which is liters, or solution rather, milliliters. Now, just so you always know, if I'm in, well, over 1, if I'm in solution, SO1 is abbreviation for solution, I want to convert it to liters. If I'm in solute, I want to convert it to moles. And if I'm in solvent, I want to go to kilograms. Now, I'm in solution, so I'm going to go to liters. 1 liter is 1,000 milliliters, so we're now in liters. Now, why do we want to get the liters? Well, I know that I have 0.7550 molar copper 2 sulfate. Copper sulfate is CuSO4 plus 2, since it's copper 2 sulfates minus 2. Sulfates inside the box, O4, 8. There we go. Now, because it's molarity, we have to make a fraction out of it. So we take 0.7550 moles of copper 2 sulfate over 1 liter solution, because remember, molarity is the moles of solid over liter solution. Now, we use that so that we can just push it right up there, and then my liters are cross out, now moles of solid. Now, I'm in moles, and I want mass. So what I'm going to have to do is find the form of mass. Copper, sulfur, oxygen. Copper 63.5 grams, remember copper and chlorine 0.5s. Sulfur is 32, and oxygen 16 times 4, 64 grams. 159.5 grams of copper 2 sulfate is 1 mole copper 2 sulfate. Make our fraction. 159.5 grams of CuSO4 over 1 mole CuSO4. Everything crosses out, multiply through. We get an answer 30.11 grams of CuSO4, and that's my answer. Now, there's another unit of concentration, and that unit of concentration is called molality. Molality is defined as moles of solvent over kilograms of salt. When you do the activity next Tuesday making Kool-Aid, you're going to be working in molality. All right, now, let's look at a problem here. Determine the molality of 345.95 grams of lead 2 nitrate in 300.0 grams of water. So, we're in molality, so it's moles of solid over kilograms of solvent. And we need to know what our substance is. Well, I have lead for PB, nitrate outside the box, O3 outside the box is nitrate. Oxidation for lead is plus 2 because it's lead 2, nitrate's minus 1. So we get PbNO3 twice. All right, so take our 348.95 grams of lead. Now, is that my solute, my solvent, or my solution? Well, it's obviously not solution because it doesn't say solution. Solvent, water is a universal solvent, so that's my solvent. So therefore, lead 2 nitrate has to be my solute. And so, of course, when we just said solid goes to moles, so we have to find formula mass. 207 grams for lead, 28, 14 times 2 for nitrogen, and 6 times 16, 96 grams. Gives me 331 grams of lead. 2 nitrate is equal to 1 mole of PbNO2 twice. So make our fraction. 1 mole of PbNO2 twice over 331 grams PbNO3 twice. We multiply through this time. We don't keep going. So we end up with 1.0542 moles of PbNO3. Remember, we said it's moles of solute over kilograms. So we have half of it. Now we just got to convert my 300.0 grams of my solvent into kilograms over 1. 1 kilogram is 1,000 grams divided by 1,000 grams. So we get 0.3000 kilograms. 4 sig figs is my answer. I'm going to get 3.514 moles of PbNO3 twice. That's my answer. All right, so here's a problem. Copy this down. We'll do this in class. And we'll also, whoa. Did I? Yeah, I guess I did. All right, so, no, what happened to it? Nope, that's it. We'll do this one in class as well. What is the mass of water needed to form 1.285 molal of hydrogen sodium hydroxide if there is 15.97 grams? So let's add 2 more problems here. So I want you to determine let's do molarity of 18 0.995 grams of silver nitrate in 255.55 milliliters of solution. And then a second problem, I want you to calculate the mass of water in grams needed to form 1.0455 molal. Let's do sodium carbonate. Oops, spelled it wrong there. Carbonate. Using 224.55 grams of solute. All right, so there's our second problem. We'll do these in class. Any questions, let me know. We're done. Take care. Be good. Bye.